If you pick up a bottle of moisturizer right now, you're holding something that is legally treated more like a food in one country, a chemical hazard in another.
And completely unregulated somewhere else.
Exactly. It's wild. The fact that it exists identically in all three of those jurisdictions, feels exactly the same every time you pump it, and it doesn't spoil after sitting in a hot delivery truck. I mean, it is an absolute miracle of modern engineering.
It really is. I mean, you look at that little bottle and it seems so simple.
Right.
But the distance between a raw chemical concept and a stable, globally compliant product sitting on a shelf, it's vast. Most consumers have no idea of the sheer computational power, not to mention the regulatory gymnastics required to bridge that gap.
Which is exactly the mission of this deep dive. We are taking apart that hidden machinery today.
Getting into the weeds.
Getting way into the weeds. And to do it, we're using this comprehensive new guide titled End-to-End Cosmetic Manufacturing. It was published today, actually, May 2, 2026, on Ingredientsage by the wellness innovator Laurent Fabian.
It's a fantastic breakdown.
It really is. It basically maps out the modern reality of how brands survive this massive complexity. And okay, let's unpack this for a second. The whole survival strategy Fabian talks about revolves around this concept of an end-to-end contract manufacturing organization, or a CMO.
Right, an end-to-end CMO.
Yeah. So I was thinking about it like this. Instead of hiring a separate plumber and then an electrician and a painter who, never talk to each other to build your house, an end-to-end CMO is like hiring a master general contractor.
That's a great analogy, actually.
Because they control the entire ecosystem, right?
Yeah.
From the architectural blueprint to handing you the keys, which in the cosmetics world means everything from the formulation strategy to post-launch recall support.
Yeah, and the reason that matters, why brands are moving this way, is all about centralized governance. I mean, it fundamentally changes a brand's risk profile.
How so? Like practically speaking.
Well, when you have disparate vendors handling different phases of development, data silos form naturally. So the chemist who formulated the emulsion in the lab might not communicate the specific shear sensitivity of a certain polymer to the factory manager.
Who might be in a totally different country.
Exactly. And that disconnect is what causes catastrophic failures when you try to scale up.
The lotion separates or clumps up.
Right. But an end-to-end model unifies that data capture. The same entity responsible for the initial stability testing is also doing the commercial scale-up, and they are building the regulatory dossier.
It's an unbroken chain of custody.
Which is what allows a brand to scale from, 1,000 units to 10 million without the formula suddenly turning into a watery mess.
Okay, so it's about eliminating blind spots. Get that. But before this master contractor can build the product, they obviously need a bulletproof blueprint.
Right, the formulation phase.
Yeah. And in the cosmetic world, reading this guide, it goes way beyond just mixing ingredients in a vat. The source talks a lot about quality by design QBD and design of experiments, or DE.
Very critical concepts in modern manufacturing.
But I read that and immediately wondered, if we have AI today that can predict formulation outcomes, why are we still doing these massive physical design experiments? Like, can an algorithm just tell us the optimal mixing temperature?
Well, what's fascinating here is that while AI is incredible at predicting a theoretical optimum, it cannot fully account for the physical variability of organic raw material.
Oh, because nature isn't standardized.
Exactly. Nature refuses to be standardized. The botanical extract harvested this year, for example, might have a slightly different lipid profile than last year's crop.
That makes sense.
So quality by design recognizes that inherent variability. Instead of formulating a single rigid recipe and just crossing your fingers, you use design of experiments to map out this multidimensional design space.
Meaning you deliberately push the formulation to its breaking points in the lab.
You have to. You alter the pH, you spike the temperature, you change the storing speed. You are basically intentionally trying to break the formula.
Wow.
And you document exactly where the emulsion fails, where the active ingredients start to degrade, and even where the sensory profile, the actual skin feel, deteriorates.
So you're finding the exact boundaries of what the formula can handle.
Right. And by doing that, you establish a safe operating window. As long as your commercial manufacturing parameters stay within that heavily tested window, the product remains stable, even if the raw materials fluctuate a bit.
Okay, that makes total sense.
Oh.
It's like mapping the boundaries of the road before you drive the car.
Right.
But taking that lab-tested formula and scaling it up, what they call tech transfer planning, that seems to be where the real nightmares happen.
Oh, absolutely. Tech transfer is where dreams go to die if it's not done right.
Like taking a delicate recipe that works perfectly in your kitchen and then trying to cook it in a massive industrial factory without ruining the texture. Why is that kitchen-to-factory leap so incredibly hard?
It really comes down to fluid dynamics and mixing energy. So
Ooh.
picture a tiny mixing blade spinning in a 100 milliliter beaker.
Okay.
It distributes energy very evenly. Almost every molecule experiences the exact same shear force. But when you move to a 10,000-liter vat, the physics change entirely.
Because it's just so much more volume.
Right, and the product near the massive spinning impellers in that vat is subjected to violent high shear forces, while the product at the very edges of the tank might, barely be moving at all.
Oh, wow. I didn't even think about that.
Yeah, and if your polymer network is shear sensitive, those giant impellers will literally tear the molecular structure apart, completely ruining the viscosity.
And that's when you get the watery mess or the cottage cheese texture.
Exactly. And that is why tech transfer is a hardcore engineering discipline. It's not just handing off a recipe card. The CMO has to characterize the rheology, which is the flow behavior of the pilot batch. Then they mathematically translate that required mixing energy to the specific geometry of the commercial tank. I mean, they adjust the blade pitch, the baffle placement, the cooling jacket temperatures, all to mimic the precise environment of that tiny beaker, but on a massive scale.
That is insane. So, okay, let's say the physical engineering is solved. We have our robust design space, the tech transfer is flawless, and we can pump out 10,000 liters of perfect product.
The dream scenario.
Right. But now we crash headfirst into the legal reality.
Yeah.
Because we had to actually sell this across borders.
And that's a whole other labyrinth.
Yeah. Reading through Fabian's breakdown of the global regulatory minefield, it is staggering how disjointed the global market is. You've got the EU, which seems to be the strict benchmark, demanding this massive, exhaustive product information file, the PIF.
Under Regulation 1223/2009, yes.
Right. They want absolute transparency on every single molecule. And then you have the US FDA, which, well, the contrast is stark.
It's extremely stark. The EU operates on a strict pre-market safety substantiation model, meaning you prove it is safe before you sell a single unit.
Okay.
The U.S., historically, has operated on a post-market enforcement model. The FDA does not pre-approve cosmetics.
Wait. I have to push back on that because as a consumer, that sounds terrifying. If the FDA isn't pre-approving these products, doesn't that make the manufacturer's own internal good manufacturing practices, their GMP, the only actual shield protecting the public?
Well, yes.
It sounds like a giant honor system.
I mean, it functions largely as a self-governing system on the front end, but the liability risks on the back end are so astronomical that reputable brands treat ISO 227-16, which is the international GMP standard, as absolute mandatory law.
Because if something goes wrong.
Exactly. In the U.S., the burden of ensuring safety rests entirely on the brand and the manufacturer. If a product causes harm, or if a regulatory body conducts a surprise audit and finds lacking safety substantiation, the brand is held fully responsible.
So they can't afford to mess around.
No. And that is exactly why end-to-end CMOs are non-negotiable for serious players now. They maintain continuous audit readiness.
The source mentions LCOA as the backbone of that audit readiness. Attributable, legible, contemporaneous, original, and accurate.
LCOA, yes. The gold standard for data integrity.
But how does that actually manifest on the factory floor, like day to day?
Well, LCOA is basically the death of the paper logbook.
Oh, really?
Yeah. Think about it. In a fragmented, old-school supply chain, a factory worker might realize a mixing tank's temperature dipped below the required threshold for, say, 20 minutes.
Uh-oh.
Right. And they might just scribble a falsified compliant temperature in a paper binder to avoid scrapping a $1 million batch.
Wow, just to save their job or save the money.
Exactly. But with LCOA principles enforced through centralized electronic dossiers, that kind of tampering becomes physically impossible.
Because the tank sensors are feeding the data directly into the dossier.
Precisely. The programmable logic controllers on the tank feed immutable, time-stamped telemetry directly into the centralized system. It is attributable to the specific operator logged into the terminal. It's contemporaneous because it's recorded to the exact millisecond it happens.
And no one can go back with whiteout and change it.
Exactly. It cannot be altered after the fact.
Yeah.
So, if an FDA or EU inspector demands to see the batch record for a moisturizer that caused a bad reaction, the dossier proves exactly what happened.
That's incredible. And it probably holds the substantiation for every marketing claim on the bottle, too, right?
It does.
So if the packaging says clinically proven to reduce redness, The dossier actually holds the version-controlled, time-stamped clinical trial data linked directly to that specific INCI formulation.
An unbroken chain of evidence. And, in a worst-case scenario, let's say an ingredient supplier notifies the CMO that a batch of botanical extract was contaminated. The dossier allows for surgical, immediate recall readiness. They can trace exactly which finished units contain that specific raw material and pull them from distribution before they ever reach the consumer.
Okay, so what does this all mean? We have the fluid dynamics solved, we've got the immutable legally dossiers locked down. But looking at the materials section of Fabian's guide, there is this massive collision happening between consumer desires and basically biological reality.
Ah, yes. The clean beauty dilemma.
Yes, because consumers today, they want clean beauty. They want organic, food-grade ingredients, minimal synthetics, and sustainable recycled packaging. But organic, food-grade material is exactly what bacteria and fungi love to eat.
It's their favorite diet.
We are essentially building an all-you-can-eat buffet for microbes and then putting it in a warm, humid bathroom for 6 months.
If we connect this to the bigger picture, you've just identified the central tension in modern formulation.
It seems impossible to balance.
It is a delicate balancing act. The marketing department wants ESG alignment, environmental, social, and governance goals. They want natural claims on the box. But the regulatory department wants a 24-month shelf life with zero microbial growth.
So how does a proactive CMO actually synthesize those opposing forces without just, dumping traditional harsh synthetic preservatives back into the vat?
It requires highly advanced hurdle technology and rigorous preservative efficacy testing, or PT.
Hurdle technology, what is that?
It's basically putting up multiple different physical and chemical barriers, or hurdles, that microbes have to overcome to survive. So it's not just one strong preservative. It's a combination of pH control, water activity reduction, and natural antimicrobial boosters.
Oh, I see.
And they don't just guess that a natural preservative system will work. They take the finished product and they intentionally inoculate it with massive concentrations of pathogens.
Wait, they actively put bacteria into the final product?
Oh, yes.
Yeah.
Staphylococcus aureus, E. coli, Pseudomonas.
That is horrifying.
It's necessary. They then measure the logarithmic reduction of those bacteria over 28 days. If the natural preservative system cannot aggressively kill off those invaders within the required time frame, the formulation fails.
It's literally biological warfare in a petri dish.
Pretty much.
And the packaging plays a huge role here too, right? Because the guide mentions packaging integrity checks specifically regarding recycled materials.
Right, because recycled plastics, post-consumer resin, or PCR, they often have different structural properties than virgin plastic.
Like they're weaker.
They can be more brittle, yeah. Or their molecular structure might actually allow microscopic amounts of oxygen or moisture to permeate the container over time.
Which would feed the microbes in our buffet.
Exactly. Or it would oxidize the fragile natural ingredients, making them useless. So the CMO conducts extreme packaging integrity tests.
Like what kind of tests?
They test the torque required to break the seal. They subject the sealed bottles to vacuum chambers to check for microleaks, and they run accelerated stability protocols.
What's an accelerated stability protocol?
They bake the product in high-heat incubators to simulate years of shelf life in a matter of months.
Wow. And of course, all of this relies on actually getting the raw materials in the first place. The guide heavily stresses supply chain resilience. I mean, we've all seen how fragile global shipping has become lately.
Oh, absolutely.
One geopolitical event, one blocked canal, and suddenly you can't get your critical emulsifier from overseas.
Which is exactly why the end-to-end model relies heavily on nearshoring and supplier diversification. A competent CMO doesn't just have one supplier for a critical botanical.
Yeah, they're backups.
They have a primary, a secondary, and a tertiary supplier, often in completely different hemispheres. They maintain strategic safety stock, and they are constantly modeling geopolitical risk and even environmental factors that might affect crop yields.
Just to ensure a brand's launch isn't derailed by a bad harvest somewhere. Okay, here's where it gets really interesting for me. Managing the geopolitical supply chain, the biological warfare and the preservative testing, the fluid dynamics of the tech transfer, and these immutable e-dossiers for the global regulators.
It's a lot.
You literally cannot do this with humans and spreadsheets anymore. It's impossible. And Fabian's guide points to this 2026 digital lab transformation as the only way this ecosystem survives.
The complexity has definitively surpassed human cognitive limits. That is why electronic quality management systems, EQMS, are foundational now.
Right.
But the true paradigm shift we're seeing is the deployment of AM-assisted formulation and the creation of digital twins.
Okay, I have to stop you at digital twins because this concept blew my mind when I read the source. You were telling me they create a virtual clone of the massive industrial mixing line.
A complete virtual replica, yes.
It's like playing SimCity, but for sunscreen and moisturizer, so you can watch a batch fail virtually before you waste real product and real money. How does the software actually simulate the physical world that accurately?
It utilizes highly advanced computational fluid dynamics. So remember the rare rheology data we discussed earlier during the tech transfer?
The flow behavior stuff, yeah.
Right. The viscosity, the shear sensitivity, the exact thermal profile of the emulsion. The AI takes all of those physical data points and feeds them into a physics engine that perfectly mirrors the geometry of the real-world manufacturing equipment.
So it knows the exact shape of the mixing blade and the exact diameter of the factory pipes.
Down to the millimeter. The digital twin simulates how the virtual fluid will behave when it's pumped through a specific valve at a specific pressure.
Wow.
It can answer questions like, will the pressure drop cause the emulsion to crack? Will a microscopic bottleneck in the piping cause excessive heat buildup and ruin the active ingredients?
That is wild.
The digital twin allows the engineers to run thousands of virtual batches, just tweaking the pump speeds and temperatures in the software. They find all the catastrophic failures in the simulation, optimize the parameters, and then deploy the perfected program to the physical factory floor.
It basically reduces the scale-up risk to near zero.
That's the goal, yes.
That is incredible. But honestly, it also terrifies me from a security standpoint.
Oh, the cybersecurity aspect.
Yeah. Think about it. If you have an AI generating your proprietary formulas and a digital twin detailing your exact manufacturing process down to the millimeter, and it's all living in an EQMS that communicates across global borders, I mean, you are the ultimate target for industrial espionage.
You're absolutely right. Intellectual property is the only true currency a cosmetics brand possesses. If a bad actor accesses your digital twin, they don't just steal your ingredient list.
They get the exact instructions to make it.
They steal the exact optimized manufacturing instructions to perfectly clone your product at scale. This is why Fabian's guide elevates cybersecurity from just a basic IT concern to a fundamental manufacturing requirement.
It's basically as important as the GMP safety standards.
In many ways, it is part of the GMP standards now. End-to-end CMOs must utilize zero-trust network architectures, strict role-based access controls, and encrypted data sharing agreements.
Because the risk is just too high.
Right. When they submit any dossier to a regulatory body or share tech transfer data with a subsidiary facility, that data has to be heavily fortified. A breach doesn't just risk a knockoff product hitting the market, it compromises the immutable audit trail that actually proves the product's safety to regulators.
So if you're a listener who is actually building a brand or an entrepreneur drafting a business plan right now, how do you even navigate this? How do you interrogate a potential master contractor to ensure they actually have these digital twins, these e-dossiers, and the supply chain resilience, rather than just giving you a slick sales pitch?
Well, Fabian provides some very practical tools for this. There's a 12-point CMO evaluation checklist and an 8-point quality system readiness checklist.
Yeah, I saw those. They seem pretty intense.
They are highly operational. They force brands to look way past the marketing. For instance, in the 12-point evaluation, it demands strict scrutiny of a CMO's transparent change control history.
Because, I assume, if they are constantly changing their internal processes or hiding the documentation of when a process failed, their EQMS is fundamentally broken.
Precisely. It shows a lack of control. The checklist also emphasizes auditing their mock recall speed.
Mock recall speed.
Yeah, a CMO should be able to simulate a contamination event and trace every single affected unit globally within hours.
That's a great test. And what about the 8-point QMS readiness checklist?
From that one, a critical factor is their non-conformance routing. When a batch inevitably deviates from the design space, how does the software automatically quarantine the product and alert the quality assurance team?
Oh, I see. It's about taking the human error out of the panic response.
Exactly. The system has to handle the failure safely. The guide also strongly advises defining your functional requirements in your RFP, your request for proposal, and demanding a pilot program.
Meaning you don't just sign a massive 5-year contract right off the bat.
Never. You force the CMO to run a limited pilot batch to prove their tech transfer capabilities and demonstrate their digital data capture in real time before you hand over the keys to your entire brand.
It's an intensive vetting process, for sure.
It is, but it is the only way to de-risk the relationship. The upfront friction of a rigorous audit preventing a catastrophic downstream friction of a failed regulatory inspection or a ruined product launch.
Right. And for you, the listener, even if you aren't an entrepreneur, even if you are just someone who bought a new serum today, this completely changes the context of what is sitting on your bathroom counter.
It really does.
You aren't just looking at a simple bottle of lotion. You are looking at the physical culmination of AI-optimized design spaces. You are holding the result of computational fluid dynamics, global regulatory dossiers, rigorous biological warfare against microbes, and highly fortified digital supply chains.
It is a profound achievement of invisible engineering. When you dispense a product that has the perfect sensory profile, remains completely stable for 2 years, and is demonstrably safe, you are experiencing the flawless execution of an end-to-end manufacturing ecosystem.
It's wild to think about the sheer density of science inside that little pump bottle. And it leaves us with one final provocative thought based on the trajectory outlined in this source material.
Where do we go from here?
Exactly. If we are already at a point where AI can predict the stability of an emulsion before it's even mixed, and digital twins can simulate the exact fluid dynamics of the factory floor to optimize every single variable, how far are we from a future where this entire machinery shrinks?
Oh, interesting.
Imagine a master contractor system so agile and an AI so advanced that it doesn't formulate and manufacture a product for a demographic of 2 million people. Imagine an end-to-end ecosystem that takes your specific genetic data, your local climate, and your personal microbiome, and manufactures a hyper-personalized product from raw ingredient to finished bottle for an audience of exactly one.
That is the ultimate frontier of the design space.
Something to think about the next time you look in the mirror.